For centuries, humanity has gazed up at the stars, dreaming of stepping foot on another world. And now, in the 21st century, that dream may finally be within our reach. Colonizing Mars. It's not just science fiction anymore. It's a possibility that's closer than we think. But how do we make this dream a reality? What innovations will pave the way for humans to not just visit Mars, but to live there? First, the journey. Mars lies over 225 million kilometers away from Earth, making it a daunting destination. Yet private companies like SpaceX are working to make this journey feasible. The Starship, designed to carry cargo and eventually people to Mars, promises to revolutionize interplanetary travel. With the capability to refuel in space, reusable rockets could bring the cost down significantly, allowing for regular missions between Earth and Mars. But getting there is just the beginning. Once humans land, the real challenge begins. Mars is a hostile environment. Freezing temperatures, high radiation, and an unbreathable atmosphere. To colonize Mars, we'll need to innovate in every area. One of the biggest challenges is oxygen. The air on Mars is mostly carbon dioxide, making it impossible for humans to breathe. Enter MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. It's designed to take carbon dioxide from the Martian atmosphere and convert it into oxygen, not just for breathing, but also to create fuel for the return journey to Earth. MOXIE is just one example of how we can use Mars resources to our advantage. Rather than bringing everything from Earth, future missions will rely on what's called in situ resource utilization. This means using materials on Mars to build habitats, grow food, and generate energy. Imagine a future where Martian soil is used to create concrete-like structures, and solar panels generate power for entire colonies. These aren't just ideas, they're already being tested. When it comes to habitats, we can't rely on tents or short-term shelters. A permanent Martian colony will need robust, radiation-proof structures. NASA has been experimenting with inflatable habitats that can be 3D printed directly on Mars, using local materials like regolith, Mars equivalent of soil. These structures could protect inhabitants from both the extreme cold and harmful radiation, providing a safe environment for humans to live and work. Food is another critical challenge. While shipping food from Earth may be an option in the short term, a self-sustaining colony needs to grow its own crops. Martian soil isn't exactly fertile, but with innovations in hydroponics and artificial lighting, scientists are optimistic about growing food on Mars. Early experiments with simulated Martian soil have shown promise, with crops like lettuce and potatoes successfully growing in controlled conditions. Imagine a Martian greenhouse where astronauts can grow their own food, sustaining themselves without relying on Earth. But what about exploration? Mars is a vast planet with a surface area equivalent to all of Earth's landmass. Humans won't be able to cover all that ground by foot. That's where autonomous robots and rovers come in. Already, we've seen the success of robots like the Mars rovers, which have been exploring the surface for years. In the future, these machines will assist humans, scouting ahead, collecting data, and even constructing parts of the colony before human arrival. Energy is another major consideration. With no fossil fuels, Mars colonies will need to rely on renewable energy sources. Solar power is the obvious choice, as sunlight is abundant on Mars, but dust storms can last for weeks, potentially cutting off solar power. That's why researchers are also looking into nuclear energy as a backup source, ensuring that colonies can remain powered, even during long Martian winters. As we look ahead, we must consider the long-term possibilities. Mars may one day host thriving human cities with its own economy, culture, and innovations, but these won't appear overnight. Colonizing Mars will require international cooperation, immense investment, and groundbreaking scientific discoveries, yet the payoff could be enormous. From advancing space exploration to ensuring humanity's survival in case of a global catastrophe on Earth, Mars represents the next giant leap for humankind. The journey to Mars will be difficult, filled with obstacles and challenges we can't yet foresee. But with each new innovation, we get one step closer. One step closer to becoming an interplanetary species. One step closer to calling Mars home. The future is out there, waiting. The question is, are we ready to take that leap?